Everybody, we are looking for a natural number satisfying three conditions here. First one, simple enough, we want n to be a cube. Okay, some people call it a perfect cube, that just cubed integer satisfactory, I think. So n is a cubed integer. Okay, is another integer. Also, we want n to have 16 divisors, and we want the sum of the odd positive divisors to be equal to 400. The odd positive divisors. And so that's where it gets a little fun. So we're looking for a value of n, and I think it's unique, although I'm not certain, so I worded it, the instructions this way. Okay, oh, don't mind him. He gets rid of the flies, scares them away. Okay, now let's start with an example. This is the sum of all of the divisors right here. It's called sigma. And notice you can just enumerate them. You can list them. 20 has the divisors 1, 2, 4, 5, 10, and 20. Easy enough. There's 6 of them. And they sum up to 42. Now notice, just you may recognize this form over here. It's a very well-known number theoretic result. This is 20 is the same as what? 2 squared times 5. Okay. All right, and so that for the 2 cubed is this part right here sums up all the divisors of 2 squared, and you can see it right here if you just take a look. 2 squared has 1, of course. 2 and 2 squared as its only divisors, right? But this is a 3-termed finite geometric series with prime common ratio of 2, okay? And so you end up getting this result right here. So you can see, this adds up to 7, right? But this fancy little result here, which is the sum of a finite geometric series, also gives you 7. Easy to verify. Okay, that gives you 7 when you, 7 over 2 minus 1 is, of course, 7. And in a similar fashion right here, what do we get? 5 squared is 24 divided by 4, that's 6. But notice this 6 right here is exactly what we got when we use this notation I want to introduce to you. I'm going to use this the rest of the session, odd, and this just means the sum of the odd divisors. Okay, just manifestly 1 and 5 are the only odd divisors, so that's equal to 1 plus 5 is equal to 6. Right? So you see, all you do really is just leave out the 2, and there you have it. If you leave out the 2, which is what you'd expect, you get the same thing as, the old-fashioned way over here. Okay, so that's an important thing as we move along. Now, so I'm going to make a claim here that our n has to be in this form. Okay, because we've seen how nice it is. You see, 400 is not really a particularly big number when you're summing up divisors, especially of any kind of powers. They add up fast, right? So 400 maybe looks large, but it's a relatively small number as far as the sum of the divisors go. Now, so, but before I make this claim, or before we get started on the claim, another possibility looms. You could consider p to the 15th. Okay. Now, this has 16 divisors, right? 1, p to the first, p to the second, all the way up to p to the 15 is 16 divisors, right? So this satisfies condition 2, right? It has 16 divisors, and it's also equal to a perfect cube. You can write it as p to the 5th quantity cubed, right? So you might think, what about that? Okay, so again, you got the 16 divisors taken care of, and you have the fact that it's a cubed integer, right? But it fails miserably on the sum of the. Let me write it down like this. Let me erase that. I'm just going to odd. And they're all. I could use sigma because it's going to be all odd numbers anyway. But odd of p to the 15th. Is much greater than 400, right? for all p, except for the pain in the butt. Two is always a pain, you know. But for any other prime, any odd prime, this is going to hold by a million miles, right? Okay, because you have powers of 15. Well, you know, I mean, it's just so that's clear, right? So this is we can't consider this. We can't consider this, all right? But this is the one we're going to try, and this is what we have to try because if P and Q are odd, meaning not two, none of them are two, it's going to be way over 400. Okay, it's going to be way over 400 for all odd primes. Now I can wave my hands all I want. You may just right above here. I'll go ahead and do the smallest one. Sigma of, or I should be saying. Oh yeah, no, never mind. Sigma of 3 cubed. See, we don't have to use the odd thing here because they're all odd anyway. But what we have here, 5. Let's do 5. Okay. Okay, and y'all, I'm doing the 2 smallest odd primes. Okay, so this is equal to 3 to the 4th minus 1 over 2 times 5 to the 4th minus 1 over 4. Okay. And y'all, this is certainly 40, right? This is 80 over 2 is 40. So that's 40 times, this is 20, 625, 624, 156. So this is times 156, right? So again, much greater than 400, right? So you see, that's why I'm pretty convinced the answer we're going to get here is unique, because it has to be in this form. We've ruled out this form. And if you try to group together 3 primes, it's nuts. You have trouble satisfying either condition 1 or condition 2. So it's, you know, this is, I think this is the force form right here. So let's go through and check out our possibilities here. And I'll use the notation odd, because again, 2 gives rise to even divisor. So odd of 2 cubed times 3 cubed, okay, is just going to be equal. We can ignore the 2 and we get what we got right here, 3 to the 4th minus 1 over 2 equals 40. Okay, not equal to 400, right? Now that was hard. Okay. All right, now let's go, let's try out the next one in line here, odd of 2 cubed I think our Venus flytrap up there doesn't like all these mouse clicks. Let's check. It looks pretty pissed off. Okay, so right here we have, oh God, I got that wrong, didn't I? Sorry. Okay, so that's, what do we need here? 5 cubed? Yep, 5 cubed. Okay. So that's going to be equal to 5 to the 4th minus 1 over 4. And we saw up here that that's already 156, right? It's 156. Not equal to 400 again. The deepest result of the evening. All right, and then so let's try out odd two cubed times 7 cubed. Again, we are ignoring the 2's. All right, so that's equal to 7 to the 4th minus 1 over 6. Okay, and this is 2401 minus 1, which is 2400. So this is 2400 over 6. That's 400. Yay! Y'all, I claim it's unique, and again, it's a fine line between hand waving and some level of rigor here. I didn't, again, you may want to mess with the 3 distinct primes yourself. They just don't work. It's hard to even get the divisors to be 16. I don't think you can. And you definitely have a hard time with it being 400. So I'm pretty sure this is the only problem, the only answer. And y'all, if you want to know the number's value, 2 cubed times 7 cubed is 2744. So our magic number, 2 cubed times 7 cubed, it is the only number in the entire universe that is a perfect cube, has 16 divisors, and has a sum of 400 odd divisors. All right, what is it again? I wrote it down somewhere. 2744. So it's special. 2744, 4-digit number, and I'm fairly certain it's unique, although the claim of a rigorous proof is being withheld. So n's equal to 20. See, he paid attention. He realizes what a momentous occasion this is. All right, 2744. Let me make sure I didn't typo you on that. Yeah, that's right. Okay. All right. Good night.